In this part of the video, things are going to get a bit real, because this is going to have the actual numbers and the actual coordinates. But it's not going to be terrible. You can do this. We're going to rotate 90 degrees, 180 degrees, and 270 degrees. We're going to do it one piece at a time. So in this first one, we are only doing 90 degrees clockwise. Clocks go this direction. So then if we write this point, we can see that it's going to start at the top. C is going to start at the top. And then if we go one thing over, C is going to end up pointing towards the right, because B is going to end up somewhere over there. I'm putting these points, but they might not go in those exact spots. Let's find out. So let's start off with C. C started at 4, 7. Up here, let's make sure let's count. The X is 4 and the Y is 7. 4, 7. Remember, the X is the first number and the Y is the second number in an ordered pair. The cool thing about rotations is that if it's a 4, 7 up here, then it's going to be either a 4, 7 or a 7, 4. The numbers in the ordered pair will stay the same because we're not changing the size of this. All we're doing is we're moving it, we're rotating it, we're spinning it. So the numbers will be the same. It's just the order might change, or the signs of those numbers might change because we're changing quadrants. Okay, so I already showed you that the C started at the top, which means it started out really high. It was at the number 7. But then in this new part that I put, in the new dot that I put for C prime, it's now very far to the right, which means it changed to be 7 for the X. So it's not going to be 4, 7 anymore. Now it's going to be 7, 4, which means I actually put this at the right spot. It is going to be a 4 on the Y, but it's not a positive 4. Now it's a negative 4. That is the correct spot. 7, negative 4. Let's look at how that changed. 4 was for the number X. Now 4 is in the space for Y. And it's negative. So the algebraic representation is you take the starting one. This is just whatever X and Y you start with. And how you're going to change it is you're going to switch Y with X. And you're going to make the X negative. Now, well, okay, whatever the original X was, you're not going to make it negative, but you're going to change the sign. We only have this one negative right now because it's in the fourth quadrant. Fourth quadrant has positive X's and negative Y's. So let's see how the other ones change. A is here, and it's going to just turn 90 degrees. What was the original spot for A? Let's look at over here to the left. It's 2, 1. That means we're going to switch X and Y. So it's going to be 1, 2. And if we look here at 1, 2, that's actually positive 1, negative 2. And we're going to have to connect this to C. It went from positive 2. Oh, it's just that this 2 needs to be negative because it's in the fourth quadrant. And then let's do B the same way. Here's the original one. It's going to move 90 degrees over. And I actually did put it in the right spot the first time. I got lucky. I just guessed, but it turned out I guessed right. It's going to be at 1 for X and negative 6 for Y. 1 for X, negative 6 for Y. In my own words, how I would describe this rotation is we switched, whenever you rotate 90 degrees clockwise, and then in parentheses it says 270 degrees, that's because, like you just saw in the last examples, 90 degrees one way is going to get you to the same place as 270 degrees in the other direction. So whenever you do 90 degrees clockwise, we switched X and Y and changed the sign of X. Or, to make this more specific, we changed the sign of the new Y. All right, let's do it again, but this time we already did 90 degrees, so this time we're going to do 180 degrees clockwise, and we're going to see how it changes. We have our original picture. If I move it 90 degrees, it would end up where we just had it. And if we move it another 90 degrees, it's now going to end up in quadrant number 3. It's going to end up in quadrant number 3, and it's going to be, if C was at the top, here's the top, now C is at the bottom, which means the entire triangle is going to be upside down. And this is going to be C prime. Now let's look at this coordinate. C started at 4, 7. C ended, remember, just like with the 90 degrees, it's going to be the same numbers. It's either going to be 4 and a 7, or it's going to be a 7 and a 4, because all we're doing is we're turning. We're not adding or subtracting or multiplying anything. We're just turning things around. So it's going to be the same numbers, but in a different order, possibly. Where I put that dot, my guess is that it's going to be around this spot, and this spot has a -4 for X, so a -4, and it has a -7 for Y. So it's not, we didn't switch anything. All we did was we changed the signs of the X and the Y. So let's write that down here. What's going to happen is we are going to change the signs of X and Y. What that looks like algebraically is we start with XY, we're going to change it to be the new part, and the new part is going to be -x, -y. So all we have to do is we're going to change all of these numbers to the negative version of themselves. Now let's graph these dots and we'll see if they end up making sense. If we really did rotate it 180 degrees and it looks the same way and it looks the right way. Okay, so the point A was going to be -2 for X, -1 for Y. So that's down here. Let me erase my circles since I'm done with them now. We turned 180 degrees, which just means 2 quadrants over. This is A prime. Now let's move B 2 quadrants around. It was at 6, 1. Now it's going to be at -6, -1. Let's connect the dots with the lines. And I'll be darned, that triangle turned 180 degrees. It was pointing up, now it's pointing down. That's done. Now let's see you get this last one well done. Try it on your own. I'll come back in 5 seconds. So So pause the video. Don't just wait for me to explain it to you. Try 270 degrees on your own. 270, which just means one more 90-degree rotation than the last one.